All right, this is going to be the first video for Note 66. The top part of these notes are talking about what makes a function a function. All right, and the biggest thing that I want you to basically pull out of this is kind of in two parts, but it says a function assigns exactly one value to each input of a specified type. Now, that's a lot of words, but basically it means when you put one x value into a function, right? The function is going to do something to it, and then you are going to get exactly one output value out, one function value, one y value out. It is a 1-to-1 relationship, okay? So there is a very simple definition. We're going to talk about what that simple definition looks like in terms of practice, where you have a set of ordered pairs where each x value is matched up with exactly one y value, okay? So we're going to do questions number 1, 2, and I think it's 3 or 4 maybe, which get into basically testing to see if you have a function or not. So question number 1 has a couple parts to it, A, B, and C, and we're just looking at ordered pairs here. It says, which of the following sets of points could lie on the graph of function? So if we look at part A, all right, and I'm just going to look at my x values. I have an x value of 2, 5, 3, 2, this is a problem, and then 6, okay? And the reason I underline the ones that I underline is because, well, in this ordered pair, I put into the function 2, and what I got out of it was the number -1. Okay, that's fine. Okay, excepting that at a different time, I put the number 2 in the function, and I got back a different y value. All right, so this is not a function. All right, I'm just gonna put down not, or you can put down no. I'm fine with either of those. So then looking at part B here, I'm going to take a look at my x values. All right, so I've got -1, I've got 8, I've got 5. None of those repeated. So absolutely, these points could lie on the graph of function. I'm going to say yes. All right. And then for the last one in part 1, which is part C here, if I take a look, I've got the x value of 9. I've got a 1 and I've got a 1, but unfortunately, those y values are different. So 1 cannot pair up with 6 and also pair up with -3 in the same relationship for it to be a function. So for part C, no, not a function. Or again, you can just write down no. So only part B is the function, okay? And then question number 2 is very similar, right? We have some more ordered pairs here. If I look at my x values, I have 9, 2, 3, and -2. None of those repeated. So is number 2 a function? Absolutely yes. Okay. And then sliding over to number 3, is it a function? And again, I just keep looking at those x values. So I've got 1, -1, 1. I said 1 twice. We've got a problem. All right, because in the first order pair, 1 pairs up with 2, and in the third order pair, 1 pairs up with -2. Is it a function? No, it is not a function. Okay, so that's what happens if you have ordered pairs. So then what's going to happen in question number 4 when you have equations and when you then have graphs? So let's talk about question number 4 for the function equations. And I'm saying function equation. We're going to test to see if these equations are functions. So one of the best ways to test is to pick a test value and to see what happens in the function. So let's say, for instance, in problem part A, I want to test an x value of 0. Right? Let's see what happens there. So y equals 0 plus 5, so that means y equals 5. Okay, so I put a value of 0 in, I got a value out, right? 1-to-1 relationship. So likely this is a function. And the other thing I would look at is this equation is y equals mx plus b, which means this is a linear equation. And yes, absolutely, this is going to represent a function. So this is a yes. All right. If you have a linear function or linear equation that has a slope and intercept, you're going to have some kind of function. Okay? All right, part B, let's say I put in an x value of 0, right? So 0 squared plus y squared is equal to 9. This 0 term is going to basically disappear. It's 0 plus y squared, which would just be y squared. But then you've got to solve for y squared here, so let's go ahead and take the square root. But here's where it gets tricky. You have to remember, when you put a square root into a problem, you have to include a plus or minus. In Houston, this is where we're going to have a problem. We put x in the problem, but we're getting back both positive 3 and we're getting back negative 3. So in this particular problem, you'd have two ordered pairs, 0, 3, and 0, negative 3. This is absolutely not a function. Okay. Moving over to part C, right? Part C and part D kind of look similar, but let's talk about, what they look like in terms of are they functions or not. So for part C, let's say for giggles, I put in an x value of 3. All right. So y is equal to 3 squared. So y is equal, well, 3 squared is 9. Okay, cool. I put one number in, I got one number out. Yeah, this looks like a function. All right. Now, how else would I know it's a function? This is a quadratic relationship, right, where you have x squared. So this is going to be a concave up graph, looks something like this. And yeah, that is a 1-to-1 relationship. For part D, again, they know it looks very similar. But let's say in part D, I don't use, I'm going to replace x with 4 this time. All right. So if I take the square root, which we just talked about this a couple problems ago, when we put that square root in, you need a plus or minus. Square root of 4 is 2. And this is where we run into problems, right? I put one number into the equation, but I'm getting 2 values back out. That is not a function. So no, not a function. What I want you to think about is in terms of your equations, if you can look at these things, right? We had y equals negative 2x plus 5, x squared plus y squared equals 9, y equals x squared, and x equals y squared. The two that were not functions both included a y squared term in them, and that's what's causing them to be not a function. Because when we solve for y squared, at some point we're going to take a square root. That's going to cause us to put a plus minus in the problem, and that's going to create 2 different values. All right, last part here is going to be E, F, and G, which are the graphs. And these graphs, you're going to test for a function by doing something called the vertical line test. So I'm going to draw myself a vertical line. All right, now the nice part about the program I'm working in is I can pick up this line and slide it over my graph, okay? And so when I slide this over the graph and I stop here at, let's say, 2, and I look at where I intersect. So this vertical line is hitting my circle here, right, in 2 different places. Got a point here and a point here. So that means when I put 2 in as an x value, I'm getting 2 up here with some positive value, and I'm getting 2 at the bottom with a negative value. That's not a one-to-one relationship. So no, you have failed the vertical line test, right? Your vertical line can only ever touch the graph at 1 point at a time. So as I move this vertical line around, all right, so as I move it left to right, yeah, I keep hitting multiple points, right? There's a point above the x-axis and a point below, so that's going to cause some problems. Part F, let's go ahead and do that same vertical line test. There's my pretty vertical line. And again, the program I'm working in allows me to move these lines as I want them, right? So now we're touching the graph, touch, touch, touch. But as I move it along, I only ever have 1 point of intersection at any given vertical line. So that is a yes, you pass the vertical line test, right? This vertical line only ever touches your graph at any 1 point at a time. All right, last but not least for part G, same basic idea here. If I take a vertical line and I draw it, I don't know, right there, Slightly better. There we go. And as I move it around, it only is ever in contact with that curve at one point at a time. So 1 point, 1 point, 1 point. So do you have a one-to-one relationship? And the answer is yes, you do. All right, this is where I'm going to go ahead and cut the video. So in this video, we talked about what makes the function a function. We tested functions from ordered pairs. We tested functions from equations, and then we tested for the vertical line test if you're given a graph. Okay, please let me know if you have any questions or concerns. I will come back with a video 2 that goes over evaluating, which is question number 5.